In this episode, I'm going to look at a Sanyo 8mm camcorder. This one was sent in for repair. We're going to take a look at it and see whether we can solve the problem on this one and save another 8mm camcorder from the dumpster. Unfortunately, with camcorders, sometimes you never know until you get into them how serious the problem is. So let's get into this one and see what's going on. Today we're using an 8mm camcorder. This one is a Sanyo. It's an VMEX-30. And the note that accompanied it said, plays back audio but no video. Audio level seems low. Have to crank TV to hear it. That's what the symptom is. Next we'll take a tape. We'll try playing my test tape. It's always a challenge when I see a camera that I haven't seen before as to how to put a tape in this thing. Controls are under there. There we go. And I don't have a very good picture at all. Take a look at what I'm seeing on the screen here. I had a bit of a picture there. It seemed to have disappeared. It was kind of jumping and flashing, and now it's gone. I did initially have a picture, but it's now completely gone. If I flip it back to camera, back to VTR, let's just see whether anything comes up when I first hit play. I did initially have a picture momentarily, and then it went away. Interesting. Okay, I guess we need to pull this thing apart and see whether it's probably going to be a capacitor, at least one. But we'll see if we can figure this one out. So let's take this one apart and see what is wrong, if we can get this one working. That's the idea anyway. So we'll start by removing some of the screws to hold the unit together. Unplug the microphone and the I guess the light. Power for the light. This one of these cameras that had a hot shoe that you could plug a video light in. Oh, it's got fuzzy logic. And of course it's got our favorite bloody surface mounted capacitors. Good chance that's where our problem is right there. Adjustment? A button for adjusting? Interesting. The question has been asked and debated. People have debated this one for years, since the video format war started back in the 1980s. And you have to remember, we had basically three consumer videotape formats. There was looks like some moisture, doesn't it? There was VHS, of course. And there was beta, and then there was 8mm. And yeah, I realized there were a couple of other formats over on the other side of the pond that never really had much commercial success and had no commercial success in North America. And there was another format too that Sanyo had. They called it the V-Cord. And the V-Cord, if anybody has followed the history of videotape, was actually one of the formats. And for those that don't know, everybody thinks that the story, as the story goes, that Sony invented beta and JVC invented VHS, and that's the end of the story. But that's actually not the case. Okay, there and this info's out there if you look for it. Sony used to put this in their advertising literature too. When Sony first made the change from beta to VHS, and they brought out their model SLV 555, right on the sales literature, it said Sony, co-inventor of VHS, and there's a lot of confusion. A lot of people think that Sony had nothing to do with VHS, but they actually did. Before VHS, if we go back in history for video recording, you go back far enough, you'll find that Ampex actually invented videotape recording, and it used a 2-inch quad format tape with 4 heads that scanned the tape almost vertically. And to edit it, you actually cut it with a razor and spliced it together. It wasn't a helical scan, it was almost a perpendicular scan tape. That was the very first of the videotape formats, and it was a broadcast format. Sony invented helical scanning, or were one of the inventors of helical scanning. They did that back in the early 1960s. A black and white reel-to-reel machine called a VC2000 used a 1/2-inch tape. I've got one. I've shown it. But that was an open reel format. The first cassette format was developed by Sony, and it was the U-matic, which was 3/4 inch, and that set the standard for broadcast. And it was the standard for broadcast for many, many years, right into the 1980s. When it came time to develop a home video format, Sony and Panasonic's parent company, Matsushita, and JVC formed an alliance to develop a system. And Hitachi was in there too, and Sanyo. But the major manufacturers were, but Sony was one of the key companies involved in the engineering. And Sony, with the others, had proposed a couple of different standards, a couple of different formats that many didn't come to fruition. The Philips one was not even on the table at that point. That was the one with the tape that you could turn over and use the other side. Anyway, as they were working to develop a format, Sony was wanting to use their expertise that they had already perfected the U-matic and scale the U-matic format down. So Sony wasn't really interested in some of the other formats that were being worked on. They developed the Betamax based on the 3/4 inch U-matic. Smaller cassette, smaller tape. Instead of 3/4 inch, it was 1/2 inch. But it used everything else very much like the system. It was a U-loading system, and it used a color system exactly the same as 3/4 inch. In fact, it used the same frequency for the luminance carrier, and it used the same color under frequency of 688 kilohertz. And they thought that everybody was all on board with this format. This is not coming apart like I expected it to. They used the same, color under frequency, and that they used on 3/4 inch. And they thought that everybody was on board, but as it turns out, JVC and Panasonic, or Matsushita, had their own idea, and they went with one of the discarded systems, which was VHS, or what became VHS, and released their own system, and the rest is history. Sanyo had their own system called V-Cord, and V-Cord was a unique. I've only seen one. I fixed one back in the 1980s. I fixed one, and it was an oddball format. It was a tape that was roughly the size of a Betamax tape. So it was roughly the size of a Betamax tape, but you didn't put it into the VCR that way. The lid was not on this side. The lid was on this side, and it was only a small lid. It was only a small slot that opened up, almost like the 3/4 inch with a metal or plastic flap. And you put it into the recorder this way, and the tape started on the right side and spooled over to the left, so it went the opposite way. The tape was pulled out like a Beta, or like a 3/4 inch. It was pulled out from the left side of the cassette, wound around the drum, and the tape went in like that. I've only ever seen one, and it was the most unique format. I'd say the guy that brought this thing in, I don't know where he got it from, but he only had a handful of tapes, and he'd only use it to record off of TV. But it was called the V-Cord system. It was Sanyo. Look that one up. Now I forget what year the V-Cord one came out. It was in the 70s. 75, 76, somewhere in there. I think they even beat the Beta and VHS to the market. But it was one of the early formats that was developed. But it used, if I remember correctly, and I'm trying to remember the models of the thing, but I think something 8000 or 8200, somewhere in there was the model number. But I remember that it worked in an oddball format. It had two speeds, a 60-minute and a 120-minute speed. And in the low speed, it only recorded one field. So it only recorded half the resolution in the long play speed. And it used two heads to play back, and it basically played each field twice. But in the long play speed, it only recorded 30 frames instead of the 60 fields. It recorded basically 30 fields, and it played them back twice. It was a really strange format. I've only ever seen one. I found it. There it is. There it is. I worked on one of these. There's the machine there. You see the tape went in sideways. It was a top loader and the tape went in sideways. And he's even got a picture of the mechanism. There's the mechanism of that machine. It was super cool, right? There's the mechanism there. But yeah, it's to say I only have ever seen one of these things in person. I fixed one once, and I think I just had to clean the heads on it. But yeah, it was a strange machine, to say the least. But that was it. And that was one of the VCR formats that was in the mix, by the way, with Betamax and VHS. Sony obviously wanted nothing to do with this thing because it only recorded in the LP speed. It only recorded half the resolution, and it played the field back twice. But I say it was a horrible picture. I remember working on this thing, it was a horrible picture. Anyway, but they had the claim to fame. It was the world's first machine that could do 2 hours because it beat VHS. And when Beta format released, the Beta machines, of course, only did 1 hour. Anyway, that's just a little bit of history on video formats. So we'll forget about the V-Cord. But if you want a collectible machine and you can find one, I'd love to have one. I mean, I really would. Not that I would ever use it. I would just love to have one just because of the history of it, the nostalgia of that machine. And you could switch it to record in black and white as well, if I remember, and it would increase the picture quality if you turned off the color. Anyway, that's beside the point. The main formats were 8mm, VHS, and Beta, and the 8mm had the best picture quality of them all. And some might wonder why, because the head drum is smaller than it is on VHS and smaller on Beta. So you're thinking, okay, the head drum is smaller, the writing speed, because the rotational speed is the same, the writing speed is going to be less. And it is, but these used a metal tape. And metal tape has a much higher frequency response than a cobalt tape, which is what VHS and Beta used, a cobalt doped iron oxide tape. So the frequency the higher frequencies and your resolution is all in terms of how high the luminance frequency is, and these had a higher frequency. They also had a higher color frequency. I think I said that Betamax used the same color under frequency. I got a sticker that's fallen out of this camera on my hand here. Someone's tape sticker is falling off. VHS used 629 kilohertz for the color. Beta used 688 kilohertz for the color under. 8mm and high 8 used 729. So not only did they have higher resolution in the luminance, but they had higher resolution in the chroma as well. So the 8mm format actually was a very good format. And had it taken off as a home format, it actually may have done something. But of course that didn't happen because VHS was already too well established, and 8mm came along more as a camcorder format kind of late in the game. I'm missing something here. There's something that's holding this together. Of course, Sanyo, you boneheads. you got a screw under here, so if you don't open up the cassette compartment, you're not opening the camera up. So the question is, what do you do if the machine won't open? You can't get that screw up to open up to open the cabinet. I guess you're kind of screwed. Pardon the pun, but clip that pops that together just like that. Okay, I've got to remove here. Of course, once I pop this off, I won't be able to control the unit. I'll unplug the viewfinder over here. Unplug the buttons. It's got a rotatable infrared, so you can, if you want to control it from behind the camera, you can turn the infrared around. If you want to control it from in front of the camera, there's the lens for the infrared. It's got a little periscope. The sensor's right here. You can see it. There's a little light pipe, and the light pipe goes in there. The sensor is right there. Still, it's down below the unit. Okay, very likely there's going to be some capacitors that are bad on here. More than likely that's what's causing this playback problem. This is the camera board, this one here. And we know that the camera puts out a picture, so that one should be okay. Pop the power supply off, and then I can pop the camera off. Okay, camera board's on the way. I want it separated so that I can work on the main board here. Plug the power supply back in. That's for the light. Of course, the capacitors are going to be on the other side of the board, right? It's always the way. I wonder if I can fold this board down and operate it with it folded down. That's that's what the idea is, if I can do that and power it up. All right, I got it all folded out. I just had to remove the AV port on the front here in order to swing the board out. The board's swung out. I've got it connected back to the power supply. Let's power it up and see whether I can play it, get anything to happen. Okay, powered up. Try the eject button here. I've got it open. We'll try loading a tape. And try playing it and see what I get. Oh, you gotta be kidding. You've gotta be kidding me. I take it all apart, and the stupid thing starts to work. Okay, I don't get any sound, but that's the input-output switch. Well, I got more than I had before. I had no picture. So, we're halfway there. I've got a picture on this thing. Oh, wait a minute. It just went out. Okay, well, that's what I had before. Okay, so maybe it still does have a problem. At least we got a place to start. The transport works. I know it's playing the tape because I have a picture. It just cut out. So let's see if we can find out why it's cutting out. So this requires using a scope. And I'm just going to start looking for signals around some of these capacitors. Okay, I got something there, but it's not video. I got very little signal there. So I'm just going to start looking and seeing what I see. If I see anything that resembles video. The one that shows the most promise so far is that one. As far as what looks like it could possibly be a distorted video signal. Look at some of these other ones here. I don't see any signal on any of these. So I powered it down for a few seconds, and as you can see, it's come back with a picture. That's interference from the plasma, that noise. That's interference from the plasma for sure. I'm thinking perhaps it's a power supply issue. Let's just plug this into my other monitor and shut off the plasma. Well, the picture just cut out, so there, I've got a picture on my little monitor. I don't have any sound, but I've got a picture. All that interference was just being caused by the plasma being turned on. Because of course I got the board open here, right? So there's no shielding. And now this thing's displaying a picture. Take a look at on the scope while I've got a picture where I'm seeing it. Where do I see the video on this thing while it's sending me a picture? Okay, video's here. I have video on this capacitor here. This cap got video. That one just has chroma. But you know, the fact that it's passing video and it's good, I don't think we got a problem with the. I don't think we have a problem with the caps on this. I'm starting to think more of a power supply problem. Maybe we lost the voltage. And I just unseated the power supply and plugged it back in. Is about all I've done to this thing since I've got it here. It might be over here on this power supply board. But it certainly still has a picture. I got no sound though. Video there. Video there. I had video here on this cap, and it's now gone to 0 or no video. What's it say here? It says VTR on, 4 volts. 5 volts. 5 volts. Unregulated. 6 volts. That's 3.9 volts. Over here, switched. Mine is 8.5. It's got nothing on it. Maybe that's the problem. Minus 8.5 has got nothing there. This one says 15 volts. What's on here? 14.8. Okay, I just let it sit for a minute and got the picture back so I can measure the voltage. That voltage is still sitting at 0, but then I'm looking at it and it's actually going to the connector that goes to the camera board. Therefore, I wouldn't expect it to have power if the camera's not on. The connector that goes to the VTR board is over here, and these voltages here are all looking to be good. I have a switch 5, which is at 5 volts. I have a VTR on at 4.7. And I have a VA 5 volt, which is sitting at 4.97 volts. And I have a picture. And I believe these had the correct voltages before. When the picture cut out, we'll watch it until it goes out, but I think the DC converter is probably okay. I don't see any voltages changing on that. So we're back to the video board here. Something is killing the picture. We'll just let it run here for a minute because I've got a picture on it again. Measure all the ESR of all these caps and they're all good. 5.4, 1.7, 5.4. These are all measuring within spec. How about these ones over here? 6, that's probably okay for that size of cap. 5.4. How about this one? 1.2. All these capacitors, or we call them crapacitors, are all measuring good, which would be expected because they're not leaking. And it's really when they start to leak that become problematic. That one kind of is not measuring. That one's measuring open. I wonder if that one is the problem. Because that one is showing as it's open completely. 22 microfarad, eh? Well, we can try changing out that one and see if it makes any difference. That one definitely tests open. These other ones are all testing good. I've just been testing them all. That one's good. And that looks good too. There's a couple on here that the ESR is a little bit elevated on a few of them, but for the most part, most of them are looking okay. I might change a couple of these ones over here that are just measuring just a little bit on the high side. Possibly. Doesn't really look like it, but we'll put a new one in there in place of that one. And then try firing this thing up and see whether we've made any change to it. I'll measure a few of the other ones as well and see if any of the other ones that measure a little bit questionable may be causing the problem. Something's happening after it runs for a bit, that's for sure. So I've changed these two capacitors here, these two 4.7's in this one over here. Let's see if we've got any difference in performance now. Let's see what happens when I press play. I got sound but no picture. Okay, we're getting there. I got sound. Now let's get the picture. It could be these caps here, even though they're not measuring particularly bad. There was a few of them that measured a little bit high in ESR, and that's what I'm doing, is I'm just gonna change the ones that are measuring a little bit out of spec. This one here is also, what was this one measuring? That one might be bad too. That one should be okay. And that one's okay. That one's okay. This one here might be bad. This 22 at what is it, 35 volts? Anyway, this one here looks like it could be bad. It's ESR is a little bit high, so we'll try changing out that one too. Well, I have a picture and sound. Let's see how long it plays for. See if it cuts out. At this stage of the game, I've changed four capacitors right here. 1, 2, 3, and 4. That's all I've changed. I got a picture and I got sound. Okay, after all this time on this thing, I know the problem. We got a bad board. Watch this. When I flex the board like this, I get a picture. Watch. There we go. I'm pressing on the video IC right in the middle of the board. The board has a fracture internal. Whoops. The board's got a fracture. If I just flex it just a little bit, it kicks in. So basically I'm putting my finger on the chip here and I'm just giving this chip a push. And there, picture just came back on. So either there's a connection on this IC. I've looked at them. I don't see any that look to be bad. But either there's a connection on that chip that's bad, or more than likely what I think's happened is this camera may have been dropped or bounced or something at some point. This is a multi-layer board, and there are connections between one layer and the next. Somewhere on this board, in this area here, there's a fracture or a break, and when it's cold it'll work for a few minutes and then the video cuts out. Now there was some bad caps that was causing the sound problem. We fixed that, but the video problem, I don't think I'm going to be able to solve this one. I spent a lot of time on this trying to localize it, and I've got it right down into this area of the board here. To say when I just put my hand on the back of the board and press on the IC there, I get the picture back. So it's either a connection on this IC or on the board here. I'm going to go over this with a microscope basically to see if I can spot anything that might be fixable. But at this point, if I don't spot a connection that's bad, we got a problem in the board here, and the thing is going to be toast. You know, see, it's a multi-layer board. It's right on the other side of these other caps over here. But right there. This is the video processor right there. Yeah, it's basically, if I even do this, I get a picture. And the board's broken. That picture's on now. It's off. Yeah, this board's got a break in it. Unfortunately, the board has a break in it. If I just do that, there we got sound. Can flex the board. See? No picture. Back, so yeah, we got a bad board on this one. So I think at this point it's time to just call it a day. So this is where I wash my hands on this unit, because we know the fault is a bad board. It's not something that's going to be repairable, and even if it was, well, the only way to fix it would be to fix it properly would be to change the board, but that's not going to happen. You're not going to get it. I've inspected the for loose bad connections on some of these chip components here. Can't see anything broken there, but when I flex the board, like that, the picture cuts in and out. So there's a break somewhere in the board, probably on one of the internal layers, and it just is something you just can't solve. Anyway, I hope you guys enjoyed this extensive tear down and troubleshooting on this little camcorder. I wish that the results had been better, and the guy that sent it to me, I told him I'd look at it, and I'm not making any money on this because I'm not charging him for my diagnostics. The only money I'm making on this is from you guys watching, so I hope you guys enjoyed looking at this little camcorder. And say we tried, but this one here is unfortunately a total write-off. Thanks for watching.